All right, we're going to go over problems 21 through 24 of the 2017 Geometry Common Core exam. And now, let's look at this example. You have to know the area of a circle, so I want you to write this down. And let's look at the information. It says in the diagram below of circle O, and it says circle O, that means that is the center point. It says GO is equal to 8. So this segment here is equal to 8, which is the radius. So our radius is equal to 8. I don't know if that would be important, but we know it now. And angle GOJ is 60 degrees. All right. What's the question? It says, what is the area? What is the area of the shaded region in terms of pi? So whenever you see in terms of pi, that just means that pi is going to be in your answer. Sometimes you'll have answers that have decimals, which means that they take the pi and put it in the calculator, so you'll just have a decimal answer. All right, so now, we want to know what's the area of the shaded region. So that's all this that I'm coloring in red. So in order to do this, the first thing we want to do is find the area of the whole thing. So the area of whole circle, and that's going to be equal to pi times the radius squared. And so that's going to equal, we're going to do the 8 squared and give us 64. So in terms of pi, our area of whole is equal to 64 pi. Now, that's for the entire circle. So what we just found was the entire circle, including this red part. So really we found all of this, the area of the entire circle. Right? But we only want the area that's right now shaded in red here, right? So what we really need to do is figure out what is this area of what I'm about to shade in blue, or what I am shading in blue, what's the area of this sector, or this part, and if I can find that area and then take it away, I'll be left with the red part. Or if I find the area of the blue part, and take that away from the whole area, which is the 64 pi, what I'm left with will be the area of the red. So, a couple of things. We know that this angle is 60 degrees. You also know that in an entire circle, the angles are going to add up to 360 degrees. So if I were to go all the way around, that would be 360. So when you have 60 degrees, you can just find the fractional part. What I'm going to do is find the fractional part that this blue part is right here. Okay? This blue part, since it is 60 degrees, means that it is 60 over 360, right? Which equals 1/6. That means that this blue part is 1/6 of the circle. So this is 1/6 of the circle. That means that the red part is actually 5/6 of the circle, right? Because 5/6 and 1/6 will give you the whole thing. So we have 5/6 of the circle. So this red part here composes 5/6 of the circle. And if the entire area is 64 pi, we're just going to do 5/6 times 64 pi. All right? So how you're going to do that? We can put that over 1. So we're going to have 64 times 5. So let me get my calculator here. I'm going to do 64 times 5. Okay, so that's 320. So now what we have is 320 pi over 6. Well, obviously I don't see that answer. So maybe we can reduce that. So reduce 320 over 6. So if I reduce 320 over 6, remember 2 goes into both those, so 2 goes into here 3 times, and 2 goes into 32, 16, add the 0. So we really have 160, don't forget the pi, so 160 pi over 3. That is the area of the shaded part. All right? Okay, let's look at number 22. Number 22, it says a circle whose center is the origin passes through the point negative 5, 12. Which point also lies on this circle? All right, so what I would do, and I'm going to go graph this. So I'm going to graph it to find the radius, and just graphing it, you know, sometimes it'll give you your answer very easily, sometimes not, but it's always going to be helpful to take a look at the circle if they give you coordinates. So let's go ahead and graph it. Remember, you have graph paper on the exam, and I'm going to go ahead and graph this. Let's look at the points we need. So our center is going to be 0, 0, right, because that's the origin, 0, 0. And it goes through the point, so that means the circle goes to this point, negative 5, 12. So let's go and draw that. So, let's see, so if I draw my, okay, so, now here, remember this is the center, so this is the center of the circle. All right, now, we know it passes through the point negative 5, 12. So if I count that, I'm going to make that point 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we had to make our graph fairly big here. All right. Now a couple things you could do. You could actually, if you have a compass, I'm going to show you something, and you'll have a compass on the exam, so you can actually use this method. So what I'm going to do here is I'm going to draw a circle. All right, now this point, and I'm going to show you a way that you do it without the circle also. Okay, this is negative 5, 12, right? So let's go back. We'll look at something here. And all right, so which point also lies on this circle? So it's going to be harder to check these 2 points here. We can check 10, 3 and negative 12, 13 pretty easily. So let's check those. So 10, 3, let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3. But that point obviously doesn't lie on the circle. So we can eliminate that. And then negative 12, 13, let's check that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. Okay, that would be a point way up here. All right, so that point's not on the circle. All right, so I'm going to say that's not right. Now, these other points are going to be a little more difficult because you really don't know where the point 2 radical 12 is, but you can estimate it. So I'm going to estimate where that point is, and maybe we can get an idea if that would be on the circle. So I'm going to go to the calculator and put in 2 radical 12 and see what numerical value that is. Okay, that's about almost 7. So it's almost 7. So basically our point is actually, this is about 7 right here. So let's just look to see if that's on here. We'll go back now. That point is 2, okay, so 11, 7. Basically 11, 7 is what I'm checking. All right, so I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. Now, it's this point right here. Now, that point is very close. Remember, it was actually about 6.9. So based on our graph and based on what I did, I don't think that we can necessarily say whether that's the answer. So I'm going to have to actually show you a different method. But let's check the fourth one, though. Because if the fourth one's way off, then we might be able to say that this one actually is our point on the circle. Let's check the other one. So that point, 5 radical 21. So let's see approximately what that is. So 5 radical 21. That's about 22.9. Wow, is that right? Yeah, that is right. Okay, let's check to see that. I don't think that's going to be our answer, right? Let's just look, though. So what is that? 5 radical 21? I should have a test with me. I don't have one on me right now. So -8, and basically, what did we find? That's about 22, or almost 23, actually. So this point here is approximately 23. So we can try -8, 23. I'm pretty sure that's nowhere near. So if we start our point and go, -8 would be, -8 would be 1, 2, 3, 4, 5, 6, 7, 8. Okay, -23 would be way up here, right? So that's definitely not on our circle, right? Definitely not on our circle. So we know that our answer is going to be number 3, actually. Now, so that's our answer right here. Now, I'm going to show you something. I'm going to show you another way also. Okay? Now, if we know a point on our circle, okay, we know this point on our circle here, right here, right? Now, we actually can figure out the radius. We actually can figure out the radius by using Pythagorean theorem. So we have, this would be 5. Now, this is going to be 12. And if you do 5 squared plus 12 squared equals c squared, you end up with 25 plus 144 is equal to c squared. And you end up 169 is equal to c squared. So c is actually equal to 13. So that means that side is 13. That's actually our radius. So this one I'm about to outline green, that's our radius. So any point needs to have, it needs to have a distance of 13. So if I look at my other points, okay, so if I look at my other points, I just wanted to go grab a test. So if I look at the point 10, 3, right? That's the first one we checked and we knew it was off. If I have that point, that's going to be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. Now, if I make a triangle here, right? This distance would have to be 13. Well, first of all, 10, 3 is obviously not on the circle. But if you had not graphed it, and you didn't see a circle, you could check it this way. You could just say, does 10 squared plus 3 squared equal 13 squared? Well, let's check. 100 plus 9 equals c squared. 109 equals c squared. Our c is going to equal the square root of 109, but that's not 13. So that means this point cannot be on the circle because it has to be 13 away from the origin. Okay, this circle, all these points are 13 away. So that's not going to work. Now, we check the third one. Let's just take a third one that our answer is, just for the sake of time. We have 11, and then we have 2 radical 12. Well, if I were to graph that and make my triangle, I'd say, okay, 11 squared plus 2 radical 12 squared is equal to c squared. And if I do that, I get 121 plus, and if I do 2 radical 12 squared, 2 you end up with 48. And you end up with 169 equals c squared. And c is equal to, the square root of 169 is 13. There you go. Just like our first point. So that's another way to do it. If I had more time, I'd go over a little more, but okay, that's another way. So that is number 22. All right, let's move on to 23. All right. Okay, it says a plane intersects a hexagonal prism. The plane is perpendicular to the base of the prism. Which two-dimensional figure is the cross-section of the plane intersecting the prism? All right, first thing I want you to do is write down what a cross-section is. All right, a cross-section is a shape we get when you cut straight through an object. It can be from side to side, which would be parallel to the base, or cutting like that, or you can cut perpendicular to the base, which would be that way. Okay? You don't have to draw these pictures. I know, I just want to have them there for you to look at. So remember, you're cutting perpendicular. So we care about cutting up and down, not side to side, because up and down is perpendicular. Remember your base, imagine your base on the floor if you place it on the ground. Perpendicular would be this way, so you'd be cutting that way. Now I have an example over here. Okay, here's some examples. This would be your plane. Think of a plane as a piece of paper. All right, if you could take a piece of paper that could cut through. Now this is parallel, so this is cutting parallel. And this plane here is cutting perpendicular. So this is cutting perpendicular to the base. To the base is what they're talking about. And same thing over here. Now notice, when we're looking at this cylinder, if you cut parallel, like the one on the left, your cross section is going to be circular, right? And you can kind of imagine that. You can see here, right? If you cut parallel, which means you're cutting this way, this is what's going to come out. That's the shape you're going to get. If you were to cut down this way, you end up actually with a rectangle. You notice that? So it's a little different when you cut perpendicular versus parallel. All right? So now let's try to imagine cutting this hexagonal prism perpendicular. Right? Perpendicular. So what type of shape is going to come out if you cut it perpendicular? Well, I'll tell you one thing. If you cut it this way, you're going to get a hexagon. But if you cut it up and down, you're actually going to end up with a rectangle. I don't have a picture that does it very well, but you can kind of see it's kind of similar. It's kind of similar to the idea of this one, right? It's basically the same. So if you can imagine cutting it down perpendicular to the base, you're actually going to have a rectangle. And you can kind of see it here, right? And it would be the same thing with a hexagonal prism, all right? And we're going to talk more about that. Depending on when you watch this, we haven't talked about this yet, but we will talk about it at a certain point. So our answer is, on this one, number 4, all right? All right, we're going to look at number 24. It's kind of tricky, but we'll go through it. It says a water cup in the shape of a cone has a height of 4 inches and a maximum diameter. Maximum, that means the greatest diameter it could have is 3 inches. What is the volume of the water in the cup to the nearest tenth of a cubic inch when the cup is filled to half of its height? All right. Couple things. First of all, we have a cone here. I want you to write the formula. Now, you do have the formula of a cone in the back of your exam. The more times you see it and write it and you get familiar with it, the easier it's going to be to use. So the volume is equal to 1/3 pi times r squared times h. All of these shapes, they have a circle involved, so cylinder, a cone, a sphere, a circle. They all involve the radius. So you always want to identify the radius. So if they tell you the diameter, you always want to think, what's the radius? What's the radius? Are they giving me the radius? So in this case, they give you a diameter, a maximum diameter, which is key, of 3 inches. So what is the volume of the water in the cup to the nearest tenth of a cubic inch when the cup is filled to half of its height? All right, so you have to imagine something here. So I'm going to go, all right, so let's imagine that this is a cup. It's shaped like a cone, all right, and it's only filled to half of its height. So let's say that it's filled to about right here, right? Okay, now the maximum diameter, that means the highest, so basically if you were to fill the entire cone up, the top of it, the diameter would be 3, but we only want half. So if the maximum diameter would be 3, then the diameter at halfway would be half of 3. So the diameter here would be 1.5. But the radius would equal 1.5 divided by 2. Remember, the radius is half of the diameter. So it's going to be 1.5 divided by 2. Now let's look at something else. When the cup is filled to half of its height. Well, the entire height, so I'm talking about over here, the entire height is 4. So that means this part is half. So that's going to be 2. So you're basically dealing with this cone here, right? And the radius of that cone is equal to 1.5 divided by 2, or you could just use 0.75. And the height is equal to 2. So now we're going to plug it into the formula. So it's going to be V. V is equal to 1/3 pi, and then r squared, so that's going to be 0.75 squared, and then times h, that's just going to be 2. And when you plug that all into the calculator, you end up getting an answer of 1.2. It can be kind of tricky, this problem, but if you look at it, hopefully it made sense. All right, so that concludes the problems. I'll move on to part 2 in the next video.